Good morning. Welcome to today's Saturday workshop, the 15th of May. Next week, it's my birthday. I accumulating these birthdays in our journey to longevity, in our journey to 120 or to 180, all the way, looking at long life and health span, right? Thank you for joining us again. My name is Charles Sine. We welcome you to another workshop in our longevity series. We've been running this now for quite several months, going through a lot of different topics. We're grateful that you find the time to join us, and we look forward for you to enjoy the workshop. Sorry, we were a few minutes late starting, so I do apologize about that. So let's get on right into it. So today, let me just give you, for people who are joining us the first time, a high level of what this journey is about and where we are so far and what we're going to talk about today. So, the journey to longevity is a measure of how long we are going to live, that's lifespan, but what is the health we are going to retain. So we want to change this graph, which is peaks at 20, and most people die at 78. We want to increase that by changing the health span. So if we are healthy, we will live longer. That's really the simple messaging, because almost 80% of Americans die from chronic illness. And so if we can be healthy longer, we're going to live longer. And that's why I was talking about 120 or 180, where we begin to look at some optimization parameters. So it's really important that you understand the architecture of what we mean by longevity and the focus on health as a driver for the length of life. So let's go ahead. So there are 9 levers in our control. And we have been talking about this. I added some. We started with, I think, 7, and I've added 2 more as we've gone along because I thought they were critical for us to include. The first one is what we call nutritional biochemistry or diet control. And it's really about calorie restriction, fasting, intermittent fasting, and diet restrictions around carbohydrates, proteins and fats, fiber and water. And we know that the critical issue, as we are all seeing in the press, is the rise of the ketogenic diet. And we know that diet and its effectiveness is significant in chronic illness, especially in Alzheimer's, Parkinson's, where we have seen results that if you increase your fat intake to 60-70% and reduce carbohydrate intake to about 10-20%, specifically with resistant starches and a small protein intake, you reverse and actually achieve significant health benefits. So I think that that whole area of diet control and nutritional biochemistry is really a very significant lever that's within our controls. And the research is already out there speaking to that in volumes. And we talked about that already. There's a workshop on that. You can go back and look at it. And it's on our YouTube channel or our Facebook, Anti-Fragility Health on YouTube. And you'll see the playlist and all the videos for this series. Stress, the big killer. All of us have to develop a stress tolerance. And stress is a composite of 4 things: sugar, inflammation, sleep, and perception. And we need to manage all those 4 things. I ask people all the time, do you sleep well? Oh yeah. Well, but then they're yawning and they have to drink coffee and all those things. All those things that have to keep you awake, or they drink boosters and energy drinks and all these things during the day. If you are being boosted by that, we know that there are underlying sleep or stress issues or hormonal issues that are not coping with your levels of being awake in the sympathetic nervous system or the parasympathetic nervous system. So stress tolerance is a really important issue that contributes to longevity. The next one is our detoxification capacity, the glutathione metabolism. We're going to talk about that some more as we look at genetics. Our ability to detox, to support the liver in the extraction of heavy metals and all the toxins, molds, biofilm from our system, and the excretion of that is a critical requirement for ensuring that we have homeostasis and flow in the system. So that lever is within our control. Sleep physiology, which I mentioned a bit under stress, really important. 1/3 of our lives is spent sleeping, and sleep has a critical metabolic contribution to our overall health. Exercise physiology, we spoke about the aerobic, maximum aerobic function, our heart rate, exercise, and the contributions to stability and the other things that exercise contributes to. We have not spoken about, we have not run a workshop on infections and allergens. Today we're going to talk on genetics and epigenetics. We have also not run a workshop on exogenous compounds, but we have run a workshop on roadmap, mindset, and transformation. Okay, let's continue with our next section, which is really the topic for today. So we've gone through the 9 levers, and we're outstanding around 3 areas we haven't talked about. And today we are going to talk about genetics and epigenetics. So let me start with some clear definitions. So genetics is what we inherit from our parents, the underlying genes from our mother and father. But what is very interesting about that inheritance is that some of the inheritance sometimes is completely from our mothers. For example, our mitochondria only comes from mothers. So when there are mitochondrial issues, which is really one of the most important diseases that affect that result in chronic illness, mitochondrial dysfunction and diseases are a really critical issue. So genetics is really important. That's why in the old days, the choice of a wife was a very important issue. You didn't just go pick any girl you loved. You picked a girl from a family where their health and their issues were really very clear. And so even though we didn't know that then, our grandparents and forefathers were actually smarter, and today we're confirming with technology that genetics is a critical part of your health. So let's explore. And what is epigenetics? Epigenetics is the expression that is impacted by lifestyle. So for example, I could inherit very good mitochondrial function, but because of my lifestyle, I could end up with an impaired mitochondrial architecture. And why is mitochondria important? It is the powerhouse of energy in the body. And if you have impaired mitochondrial function, then you have fatigue, and you always have weakness and tiredness and all those things that result in a lot of challenges. So we're going to talk about genetics and the underlying susceptibilities of the genetics and the epigenetics that arises from lifestyle issues. So let's walk into that space. But to create an overall architecture of how to have that conversation, we are going to explore the big biological areas that really create significant contribution to chronic illness. So number 1 is lipid metabolism. What are lipid metabolism? It's fat metabolism. The body or the liver as the fat manager, the choreographer of fat, because almost everything in our brain is fat. All the passages are fat. Lipids, fats, cholesterol are critical for optimal body function. And therefore, the transportation and management and metabolism of fat is a critical function. It's actually one of the early areas of signs that we have chronic illness issues. Some of that is inherited. So if we inherit, and the genes responsible for that are quite a few genes. We have about 5 of them: LPL, CATP, APOC3, APOE, and PON1. So there are quite a few genes. And so when we inherit these genes, the contribution is that we have an impaired lipid metabolism. And therefore, for us to fix that, it's something we're going to be talking about implementation. But it is important that you know whether you have that impaired lipid metabolism. The second area is methylation. Methylation is a very complex biological system, biological process. And methylation shows up especially when we look at things like autism and a lot of other illnesses. We find methylation showing up in very powerful ways. Yes, sorry, I was just looking at my notes here. So when methylation is impaired, typically it shows up as that genetic mutation on the MTFHR gene. And methylation affects what we call the glutathione biochemistry. And that's the B12 folate metabolism. That is really at the source of reducing oxidative stress. Part of it. But also, it contributes to cholesterol and other mechanisms. So methylation is also something that accrued with aging. So if you have a genetic challenge with methylation, quite a few genes are affected by that. MTFHR, so we have then problems with B12 metabolism or folate metabolism, which actually leads to increased homocysteine, which are indications that we have serious impairments in all the things that arise around that. The next one is detoxification. So if you inherit detoxification impairment, it means that toxins accumulate in your body, and the body or the liver does not have the biological mechanisms for extraction. We know, because we have discussed the detox process last week, that the detoxification process is a very complex and heavy enzyme-driven process, because we have to, most toxins are locked in the body in fat. We have to release the toxins out of that using enzymes. We have to then convert these toxins into soluble, from fat soluble to water soluble, so we can excrete them and without them causing damage to the system. The detoxification pathway, when it's impaired, leads to accumulation of toxins in the body and the consequences that arise from that, whether it's cancer and all the other things. Inflammation, that's another thing that we inherit. Lots of genes around that. As we all know, inflammation is a good thing. The challenge is when inflammation is impaired, is that inflammation is not resolved. And so we have chronic inflammation because the inflammation persists. And we know a lot of illnesses are driven by inflammation, like arthritis, Crohn's, IBS, and all of those things that are inflammation driven. And we also know that inflammation, an impaired inflammation, makes you very vulnerable to COVID-19. So having an impaired inflammation, whether it's genetic or epigenetic, leads to chronic illness. The next one is oxidative stress, which I explored already when we spoke about methylation. But here, when we look at oxidative stress, we're actually looking at impaired mitochondrial function. When we have impaired mitochondrial function, as I was saying, the mitochondrial diseases and the mitochondria itself is an inherited organelle. I'm going to take a step. Mitochondria was actually a bacteria that the cell incorporated and became synergistic. So we originally, cells did not have, cells made their own energy, but it was not as efficient as this mitochondria that the body stole, or the cells stole, and became partners in that cellular architecture. So the mitochondria has its own DNA on top of the cellular DNA. But in that collaboration, the mitochondrial DNA's job is to sense our energy requirements through oxygen sensing to help with the production of energy, or ATP, from the biphosphate to the triphosphate, the ATP, which is the adenosine triphosphate. So it comes from the biphosphate to the triphosphate, and it's it takes that extra phosphate through an oxygen carrier process, or what we call electron transfer process, to create energy. So when there's an impairment, it leads to oxidative stress, in that the mitochondria is not working optimally, but also the products of the mitochondria are not being removed through methylation, the glutathione process. That's job is the main antioxidant in the body. So the energy production machine chokes from the fact that the exhaust, which is the reactive oxygen species, is not being extracted, so it chokes the engine. It's like a garage that a car is running. After some time, there'll be lack of, the car is going to stall because the air becomes overwhelmed with carbon dioxide. That's what happens with oxidative stress. And we know that oxidative stress has a powerful contribution to chronic illness. We then have bone and joint health, both inherited and both from epigenetics, from lifestyle. And then we have the big bad boy, insulin sensitivity. This is what's killing all of us. The sugar architecture. Insulin, it's the hormone that is released for the body, and insulin's job is to carry sugar to the muscle. So when the body is insulin sensitive, it means that the minute sugar is released into the bloodstream, the insulin molecules carry that sugar to the muscle, where it is used for immediate energy supplies. During the waking period, when we spoke about the master hormones last week, we spoke about cortisol, adrenals, and insulin is critical in supporting that architecture, because our response to being awake and fight and fear and flight is supported by the availability of glucose in the muscular architecture. So insulin sensitivity and the impairment of that is what's leading to a lot of metabolic diseases like diabetes and all of the challenges around that. Some of that is inherited and through genetics, and some of that is from epigenetics. So when we look at these biological areas and the susceptibilities, we begin to see that, and research is pointing that 30% of this impairment comes from genetics, and the other 70% comes from epigenetics. And therefore, since we are inheriting, our only choice towards longevity is to then work with that 70% contribution, which is the epigenetic contribution, and which is all driven by lifestyle. So now let's look at how does one then use lifestyle to change, or to change the architecture of the control that we have. We have built what we call intervention strategies, lifestyle intervention strategies, where we have prevention and optimization, we have prevention and reversal, prevention, reversal, and optimization. And what is prevention? Prevention means that you, after your diagnostics, do not currently have any clinical imbalances. But you want to focus on the genetic impairments that you have inherited. And therefore, we provide a foundational, and the FDA has provided that, and it's called the RDA, the recommended daily allowance for all human beings from a nutrient perspective. And that nutrients, those levels, are then for each individual gender and age are adjusted accordingly so that you are receiving the optimal. That is prevention. Reversal is a strategy for when you have developed through genetics and or epigenetics some of these impairments, or these impairments have already led to disease expression. We need to appreciate that just because you have the impairment, it may not have led yet to a disease state, because it takes quite a long time for this impairment or combinations of them to lead to a disease state. So reversal covers that whole space of where we have identified an impairment, and that impairment has already shown up in the lab or diagnostic results, and we want to then address. And so we use a reversal strategy. We want to reverse back to homeostasis. That's the objective of reversal, turning the clock back to homeostasis so we can be in equilibrium. Our optimization strategy really addresses the issue of efficiency and effectiveness. How quickly do I want to get back to homeostasis, and what available strategies are available for that? So our combination of strategies leads us to say, for some people it's only prevention. For some people it's prevention and optimization. For some people, for example, athletes, a lot of athletes today can continue playing tennis or football or boxing at very top levels even as they approach 40s, because that is the strategy they are pursuing. They are getting stem cells, they are getting exosomes, they are getting NAD, they are getting peptides, and we're going to talk about that when we discuss exogenous compounds. All these things that are being used for optimization. And these are all the products we are knowing today, like metformin, like rapamycin, which are all the products that support us to increase lifespan. So let's look at, finally, one of the most challenging issues as we look at all of this: mindset and what I call grit. What is mindset? It's the lens through which we look at life. And a growth mindset gives us the opportunity to see all that is possible. A long and lengthy, healthy lifestyle is possible for all of us. And if you have the mindset that's oriented towards that, then you can commit yourself to what we call grit, which is a commitment to the long game. And it is delayed satisfaction, delaying the pleasures of life, delaying. So when you delay gratification, right, then there's more pleasure in the outcomes and the things come. We all know that people who delay gratification are the ones who are most successful in life. The research is clear about that. We all like sugar, but you could limit yourself to just 1 teaspoon of ice cream, and that is enough, so that you can live a long time and enjoy multiple 1 spoon of ice creams for a long time, rather than eating a whole tub of ice cream at one sitting. So your mindset, a growth mindset that understands the long game, is a critical final tool in understanding the genetic impairments that we inherited, the epigenetic impairments that arise from the choices we make about our lifestyle, for us to be able to take control of our health span and lifespan. So thank you for joining us today in this very challenging topic. God created complex lives. Our biochemistry is very complex. So as we walk through this, it is important that you travel with me. And I appreciate your patience and the opportunity to be in conversation on these topics. I thank you. Like us, love us, leave your comments on Facebook and on YouTube, and have a wonderful weekend. Thank you again, and do send us your comments and like us. Appreciate it. Thank you.